Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if the way you speak changes depending on who you are talking to, or where you are? Well, this study dives into exactly that, looking at how social context might affect our voice pitch. Imagine you are at a job interview versus chatting with your best friend. Do you sound the same? Probably not. And one way we can change our voice pitch is by consciously or unconsciously adjusting it based on how formal or informal the situation is. This research team wanted to see if this happens in Korean, a language where social distance between speakers is super important. They gathered a dataset of voice pitch measurements from speakers in both formal and informal settings. Think of it like this: their mission was to figure out if people speak with a higher or lower voice depending on whether they're being super proper or totally relaxed. Looking at the data visually, they saw that generally in formal situations, people's voice pitch tended to be a little lower than in informal ones. For example, the plot shows that the red distribution for formal sounds is a bit to the left of the blue distribution for informal sounds. It is like a subtle shift in your voice. But the big question remained, is this difference big enough to really matter? Or is it just noise, just a random little flutter in the sound waves? To get a real answer, they built a special computer model. This isn't just any old model, it is a Bayesian model. Now, Bayesian inference is a way of thinking about data that lets us test not just if something is different from zero, but how much evidence we have for it, and even evidence for it matching a certain range of values. In simpler terms, instead of just saying yes, there is a difference, or no, there is no difference, like older methods, Bayesian stats can tell us how strongly the data supports one idea over another. They use this model to look closely at the relationship between social context and voice pitch, while also accounting for other things like the speaker's gender and the sentence they were saying. After running their model with the data, they saw something interesting. The model showed that after looking at the actual voice recordings, the most likely pitch difference between formal and informal contexts was positive, meaning informal contexts tended to have higher pitch. The red line shows their initial beliefs before seeing the data, and the gold line shows their beliefs after seeing the data. You can see the gold line, the after data belief, is mostly shifted towards positive differences. This suggests there is some evidence that the context matters, but here is where it gets really interesting. The researchers didn't just want to know if there was any difference, they asked, is this difference meaningful? What does meaningful even mean? For voice pitch, they connected this to something called a just noticeable difference, or JND. This is basically the smallest change in sound that a listener can reliably detect. If a pitch difference is smaller than what a person can easily hear, does it really matter for communication? So they defined a region of practical equivalence, or ROPE. This is a range of values that are considered practically the same, essentially meaning they're not meaningfully different. They chose a ROPE between -10 and 10 Hz. If the pitch difference fell within this range, they considered it so small that it wasn't practically significant. This is a much more nuanced way to test hypotheses than just looking for a difference from zero. Now, to quantify the evidence for their hypotheses, they use something called Bayes factors. Think of a Bayes factor as a way to compare two competing ideas. It tells you how much more likely your data is under one idea compared to another. If the Bayes factor is greater than 1, the data supports the second idea more. If it is less than 1, it supports the first idea. They use this to compare the idea that the pitch difference falls within the not meaningfully different ROPE against the idea that it falls outside of it. They did a calculation using the data from their model. They looked at the samples of the pitch difference from their prior beliefs before seeing the data, and their posterior beliefs after seeing the data. They found that after seeing the data, the probability of the pitch difference being within the ROPE, meaning not practically different, was about 0.615. The probability of it being outside the ROPE was then about 0.385. Using these numbers, they calculated a Bayes factor. The Bayes factor in favor of the null hypothesis, meaning the pitch difference is within the ROPE or practically equivalent, was about 0.615. This means the data slightly favors the idea that there is no meaningful difference in pitch between formal and informal contexts. Conversely, the Bayes factor in favor of the alternative hypothesis, meaning the difference is outside the ROPE, and therefore meaningful, was about 1.62. But here is a crucial part: these results can be sensitive to the specific choices made. They performed a sensitivity analysis, meaning they reran their calculations with different ROPE sizes and different prior beliefs. They explored ROPEs from 0.3 Hz all the way up to 40 Hz. And used different prior probabilities for the standard deviation of the pitch difference. What they found is that the Bayes factors were indeed quite dependent on the ROPE size. For smaller ropes, the evidence leaned towards the difference being meaningful, favoring the alternative hypothesis. However, as they increased the rope size to reflect larger, just noticeable differences, the evidence shifted towards the null hypothesis, suggesting no meaningful difference. This highlights that what we consider meaningful really changes the outcome of our statistical tests. They concluded that their data didn't provide super strong evidence either way, suggesting that while there might be a tendency for pitch to change slightly with context, it might not always cross the threshold of being practically meaningful according to their definition. So, what does this all mean for us? Traditional methods often just tell us if something is statistically significant, meaning it is unlikely to be due to chance. But this study using Bayesian methods and the concept of ropes pushes us to think deeper. It forces us to consider what constitutes a meaningful effect in the real world. Rather than just relying on arbitrary statistical cutoffs, it's about asking not just, is there a difference, but is this difference big enough to matter? This research encourages us to be more precise in our hypotheses and our interpretations. Instead of just looking for any difference, we should define what we expect a meaningful effect to look like, and then use tools like Bayes factors to quantify the evidence for or against those specific meaningful hypotheses. It's a more rigorous and ultimately more informative way to understand our data and its implications. This approach helps bridge the gap between theoretical ideas and concrete predictions, leading to more meaningful results for meaningful hypotheses. This was a fascinating look into how we can test our scientific questions with more depth. If you enjoyed this breakdown, please give this video a thumbs up, leave a comment below with your thoughts on voice pitch and social context. And don't forget to subscribe to RUBIN'S Mind Lab for more explorations into the amazing world of psychology and science. See you next time.